He is a graduate of the mechanical engineering program here 2 years ago. And he has been working in the gas, well, one of the projects he's been working on is with the gas station industry, looking at redesigning these things. And he has very kindly loaned us really one for each of the tutorial sections. All right, so you have a tutorial, you'll have access to this. And you also, if you need to get a hold of it outside the tutorial, you can visit Abby and Adam in ETB 119 to take a look at or borrow for just a few minutes. To help you with your project. So, Devin, being a mechanical grad and an entrepreneur and a creative guy at the same time, can tell you a little bit about what he does, where he's going with his work, hopefully inspire some of you to do something similar in the future, and he'll tell you a little bit about designing these things. Give you a little bit of insight as to what that might mean for your own project. So please welcome Devin.
All right, good morning, guys. I'd like to start off with a short video.
First up, childhood friends from Brampton, Ontario, who say their tiny invention has huge potential.
Hello, Dragons. My name is Devin Ramphal.
And my name is Michael Peckray.
We're from DRAM Innovations in Brampton, Ontario. And our future now, energy innovation, is a fuel nozzle drip retainer. Currently, what happens at the gas stations, when a customer removes a nozzle from the fuel tank, a number of drops falls to the ground. We've designed a method of retaining these drops, which makes the whole pumping process much more efficient and much less wasteful. Let's demonstrate. Here we have a nozzle without our attachment, and here we have one with our attachment. As you can see, the flow continued to flow even after he released the trigger. Now we'll try one with our attachment on it. As you can see, the flow stopped almost instantaneously and was virtually dripless.
Now I know these drops may not seem like a lot, but on a global scale, a lot of fuel is wasted due to the accumulation of these drops. Now the fuel which falls to the ground and is evaporated into our atmosphere leads to the production of smog, which is detrimental to the environment and our health.
This whole program is about future now. That's exactly what we've done. We've looked into the future, saw a problem, and brought the solution to now.
It's not a matter of if this technology will come into play, it's only a matter of when. And this is why we feel we should win the shop prize of $100,000.
Great, thanks guys. Thanks for the pitch. I'd like you to go wait in the back.
Thank you.
All right, so that was our design last year of June 2012. So that was a special energy innovation episode of Dragon's Den, where our fuel nozzle drip retainer came second place across the country. So a little bit about myself. I'm a McMaster grad, graduated 2011 in mechanical engineering. And since then, I've been working at General Motors as a manufacturing project engineer. In addition to that, I've also started my own business called DRAM Innovations. A little bit of background about why I started my own business. My first business venture was actually when I was in grade 5. And what it was, essentially, I spent all of my birthday money. It was $400, and I bought a 1-speed CD burner. And what I did was I was copying CDs for people and walking around the playground with a list and selling games and CDs to people. That business venture ended pretty quickly after the teacher found out what I was doing. Second business venture was a couple years later, grade 7, bought a scanner and I started blowing up pictures and editing it for people. And I got bored of that pretty quickly as well. So here I am on my third try, right? They say third try's a charm, so here we go. I'd like to start off by asking the question, what is engineering? What does it mean to you guys? Show of hands. Go for it.
Solving problems.
Good. Anybody else?
Design and build.
Good. So first one was solve a problem, second was design and build. Go for it.
Making the world a safer place.
Good, excellent. All right, so all good answers. And none of them are wrong, they're all right. In addition to that, engineering is creativity. It's the ability to create something from nothing. It doesn't have to be technology that you're engineering. You could be engineering a new business model. You could be engineering a new process. So it doesn't just have to be a technology. In addition to that, it's technical expertise. When you guys graduate, you're going to come out as an electrical engineer, mechanical, whatever it may be, but that'll be your expertise. So you're now going to have a toolbox to walk around life with, and you'll be able to draw from everything you learned here. Above all, probably the most important is the work ethic that you learn here. It'll be like no other. It'll be relentless. You'll be able to do almost anything. How many people want to own their own business eventually? Awesome. So what does entrepreneurship mean to you? Anybody? Go for it.
Exploring potential investments and the benefits of the future income.
Okay, so one was exploring potential benefits and future income. Anybody else? All right. So entrepreneurship is innovation. It's an idea. It's something hot. It's something that's new. Something that's unique. It doesn't necessarily have to be disruptive, but it can be something as small as maybe opening up your own pizzeria, right? And your model, the way you operate your shop, will be slightly different than how the guy down the street does it. So it's innovation, it's an idea, and more importantly, it's taking action on an idea. People have ideas every day, but what differentiates a regular person with an idea from an entrepreneur is the ability and drive to take action on that idea. And not just take one action, but take multiple actions and persevere. So what do you get when you bring engineering and entrepreneurship together? Now you have the drive and ability and motivation to take action on an idea, but not only that, you have the technical expertise to back it up. So now you have this toolbox that you can draw from and actually bring your idea to life. So a little bit about DRAM Innovations and what we do. Essentially, how many people here pump gas? Show of hands. Awesome. So you're going to know inevitably you're going to drip some fuel to the ground when you take the nozzle out of the tank. We found that globally this adds up to about 300 million liters of fuel every year just because of those drops. To put that into perspective, that's like a BP-sized oil spill happening every 2 years. Our technology mitigates those losses and saves millions of liters and millions of dollars of fuel every year. So what's the big deal with spilled fuel? Spilled fuel is detrimental to the environment. It spills to the ground. It contains volatile organic compounds which evaporate into our atmosphere and contribute to smog. It's harmful to our human health, right, when we breathe it in. It contaminates our water systems. It costs the gas station money in maintenance. And last but not least, it's just messy and undesired. We don't like to get it on our shoes, on our clothes, or on our car. So I know you guys are doing a project on the whole fueling process and trying to make it more ergonomically friendly. So I'm going to talk about the nozzle aspect and how it works and hopefully give you guys some insight. I'll start off by identifying all the different components of a nozzle. Now, it's going to be a lot of information to take in. So if you guys have any questions, feel free to throw at me. Just put your hand up. One of the main components is the poppet valve. So this is what allows fuel into the nozzle from the hose. The hose is attached on this back end here. We have the poppet valve stem right here. So this is just the stem of the valve. It's in direct communication with the handle. So as the handle moves upwards, it'll displace the poppet valve upwards and allow fuel into the nozzle. We have a device called the plunger. I'm going to talk about this a little more. We have the Venturi unit, which is crucial in the automatic shutoff. And we have our spout here, where the fuel actually gets dispensed from, and our automatic diaphragm shutoff mechanism up here. So I got a short clip here from OPW, which kind of shows how it works. Notice as the user actuates the handle, the poppet valve stem displaces, allowing fuel into the forward portion of the nozzle. Alright, so here I just got an actual image, it's not a CAD image of all the components. We got our poppet valve components here. Notice that big spring? That's what you're compressing every time you pull that handle. So, a quick hint for ergonomics, right? If you wanted to make a nozzle more ergonomically friendly, you may have to do something with that spring constant. Second component, poppet valve stem, you can see it protruding a little bit from the bottom. We have our plunger unit right here, which is also attached to the handle. Our Venturi unit right there. The check valve that fits inside of the Venturi unit. The spout, where the fuel gets dispensed from, and we have our automatic diaphragm shut-off mechanism there. So I'm going to talk about actuating the nozzle. I'm also going to be passing some parts around while I talk about this. And let's talk about how fuel actually gets into the nozzle. So if you just go to a gas station and don't touch if you don't choose your fuel grade or you don't prepay, you just go there and try to pump gas, gas isn't going to come out. That's a feature in the nozzle called the no pressure, no flow mechanism. And basically how it works is like this. Without any fuel pressure, this is your pivot point. The handle pivots about the valve stem, and the plunger moves up and down. As soon as you turn the pump on, fuel enters from the hose, right here, bypasses up to the diaphragm, pushes this diaphragm mechanism downwards. I'm going to pause right there for a sec. So what happens when this diaphragm comes downwards, there's a pin in there called the latch pin. That is, it'll be hard to see, but you'll see it when I pass it around. There you go. So that latch pin displaces these 3 ball bearings. Okay, it separates them out and they sit on a shoulder. That locks this plunger mechanism into place. So now you've essentially removed the degree of freedom from your system. And since this guy's locked, the only way, this turns into your pivot point. So now you're compressing that valve stem upwards. So please, I'll finish up this video here. Alright, and you can see that once this moves upwards, fuel is allowed to travel through the nozzle. So I'll play that one more time because there's a lot of information to take in. Pivots about the lever or the valve stem when there's no pressure. Plunger is translating up and down. Pump pressure is turned on. Compresses the diaphragm downwards. Ball bearings separate, lock the plunger mechanism, and now you can move your pocket valve up and down. Okay. Pass these guys around. I'm passing the spout around as well. The corners are kind of sharp, so be careful. Alright, so here we just got an image of how that latch pin works. It's somewhat shaped like this. It has a shoulder on it, and as it translates downwards, it pushes the ball bearings sideways, locking them into place. And here are your 2 pivot points. Your initial pivot point is here, and when the flow turns on, your pivot point is here.
Devin,
Yeah.
can you just point out on that diagram again where the latch is?
Sure.
Latch pin.
The latch pin is actually right up in here. It falls in the center of these 3 ball bearings. So when the nozzle comes around, you'll be able to look inside and see the pockets where the 3 ball bearings fit. Any questions on that? Go for it.
So like, how much pressure is required to like activate the latch pin mechanism? Like very little or a lot?
It's not much. All it needs is the pump to turn on. And as soon as that pump turns on, that latch pin drops. Anybody else? Okay. How many people here are familiar with the Venturi effect? Show of hands. Awesome. For those of you that aren't, essentially what it is imagine standing by a rushing stream. Okay? And you got all this water rushing past you. You're going to feel a breeze in the same direction as the water. So that water is almost pulling the air with it. Nozzle operates on the same principle. What happens is we have a device called a Venturi. And fuel flows directly through the center of it. It flows very quickly and through a contraction, right? Or contraction, sorry. And we got these 4 little holes on the circumference of the Venturi. As the fuel flows through the center, air flows through these holes. First component of the automatic shutoff. Second component is our sensing port. If you guys ever looked at the bottom of a spout, you'll see the small little hole right here. That's called your sensing port. That's what's in communication with your fuel tank. That's what tells the nozzle that, hey, the tank's full, I should shut off now. So that suction from the Venturi, it draws air from here, from the sensing port. Air travels through the spout, through an airline, exits the spout adapter here, and gets drawn back through the Venturi. So that's where that suction happens that we talked about in the last slide. And from there, the air exits through the spout with the fuel. Alright, so let's bring it all together now. When your tank's full, fuel level rises, blocks off that sensing port. So now, your Venturi can no longer draw air from here because it's blocked off by the fuel. So what does it do? It looks to draw air from the only available pocket or only available source that's left. That's your diaphragm. So what happens is your diaphragm starts to flex upwards and it pulls that latch pin out of the ball bearings and that disengages the handle. So that allows this guy to snap back into his home position and your nozzle shuts off. Any questions on that?
I thought that what filled the diaphragm was the pressure of the gas.
Okay, so the question is, what we think or what we thought filled the diaphragm was the gas. So the answer is that in the diaphragm there's two separate compartments. There's one for gas and there's one for air. They're completely isolated from each other, so the gas will never get into the air compartment. But what happens when the pump pressure is turned on, the gas compartment pushes the entire air compartment down. And then when the Venturi effect happens, or when we block off that sensing port, the air compartment contracts upwards. So the fuel compartment doesn't move at all. Does that answer your question?
Yeah.
Okay. Alright, so now we talked about how the nozzle works. Let's talk a little bit about the industry. With your particular project on designing a more ergonomically friendly system, you had a couple of options. Your first option would be if you wanted to integrate your technology into the fuel nozzle itself, you could take it to the nozzle manufacturers and market it to them. And you could end up licensing your technology and getting royalties or selling your intellectual property just outright. This, again, your target market now are the nozzle manufacturers. It requires the least amount of investment because now you're just essentially designing and patenting your technology. And this probably brings the least amount of revenue, depending on your licensing agreement. Your second option is you can sell a retrofit to gas stations. So this is an apparatus or a stand or some kind of retrofit you can fit onto the nozzle. You can go to the gas station themselves and say, hey, look, I got this cool new device that'll make it easier to pump, and you'll get more customers. Your target market now grew. You're not just targeting nozzle manufacturers. You're targeting all the gas stations. This requires a significant initial investment because now you have to actually manufacture your technology. This will bring intermediate revenues. Your third option would be to sell a retrofit to fuel consumers. So these are the guys actually pumping fuel. You can maybe sell the device at Walmart where they can go pick it up and clip it onto the nozzle every time they want it to pump gas. Now your target market grew even more because your target market's anybody that pumps fuel. This again requires a significant initial investment and requires and brings larger revenue because you have a bigger target market. Of course, depending on how it sells. All right, so we've identified our market. Now let's size it. How many gas stations do you guys think are in Canada? Take a guess.
500,000.
500,000? Anybody else? 600,000? All right, what about the U.S.? How many gas stations do you think are in the U.S.? A million?
Less than McDonald's.
Less than McDonald's, all right. In North America, there's 130,000 gas stations in total. In Canada, there's about 12,000, and in the U.S., there's about 118,000. Notice that it's proportional to our population, right? We have about a tenth of the population of the U.S., and they have 10 times more gas stations, roughly. Okay, so this is for options 1 and 2, if you wanted to license your technology or if you wanted to sell to gas stations. Averaging about 8 to 10 nozzles per station, that translates to approximately 1 million nozzles in North America.
So a million was similar.
What's that?
A million, I guess, was close. It's a million nozzles.
Yeah, if you look at it like that. Alright, so and your total potential market is, for the nozzle manufacturing industry, is $10 million US. If you sell about 200,000 nozzles a year, 50 to 70 bucks a pop, $10 million US a year. So not bad. If you wanted to go option 3 and sell a retrofit to fuel consumers themselves, there's 193 million licensed drivers in the US. 33 million of those are older drivers. So these are the guys that have been using their hands for 80, 60 years. They have arthritis and hand pain. So that's significantly larger market. At DRAM, our focus is on licensing and selling technology. So we come up with a cool new design, a cool new development. We take it to the industry leaders and say, hey, look what we got. We got this cool new technology. Would you like to buy it, or would you like to license it from us? So some of the industry leaders in nozzle manufacturing are OPW, Husky, Catlow, MCOE, and Fill-Rite. OPW owns the largest amount of market share. If you go to a gas station, chances are you're going to be using an OPW nozzle. You'll see Shell, Esso all use OPW. Petro-Canada uses Husky. I think Costco and Canadian Tire may also use Husky as well. So let's talk about some market trends. Do you guys think the number of gas stations is increasing or decreasing? Decreasing? Why? Just a guess? Sorry? Increasing? Why? More people? Okay, good guess. Anybody else? Sorry, go for it.
Decreasing because cars getting more fuel efficient.
Okay, decreasing because cars are getting more fuel efficient.
Decreasing because gas is more expensive, it's harder to open a business later.
Okay, decreasing because gas is getting more expensive and harder to open up a business. Good guesses. All good guesses. So the answer is number of gas stations is decreasing. Reason being is that there's a lack of profitability with gas stations. The profit margins on fuel are pretty low, and in addition to that, fuel companies also realize that we're going to buy fuel regardless of the number of gas stations. We need it, we're going to drive the same amount. And so what they've done is they've strategically reduced the number of gas stations. They've looked around and they saw gas stations that weren't making as much money and shut them down. We have two charts here. We got number of gas stations from 1994 to 2007 and our fuel consumption. We can see a general decrease in number of gas stations, whereas if we looked at the same time period, in fuel consumption, you can see our fuel consumption increase in that time period. So you can see they're almost inversely proportional to each other. So let's talk about some of the regulations and general practices in the industry. Nozzles and typical other fuel equipment like pumps and hoses typically have to be replaced every 5 years, and that's if they're not broken beforehand. Fuel nozzles generally take a beating. If you ever go to a gas station, look at the end of a spout, it's all usually banged up unless it's brand new. In the industry, there's a big focus on safety. We got designs such as the anti-tip mechanism, which is built into the nozzle, where if your nozzle falls out of the car, it'll shut off by itself. There's designs like the breakaways. So if people leave a nozzle in their car and drive away, which happens a lot more than you think it does, then it'll break away and it won't spill as much fuel everywhere. There's a focus on repeatability, and this is very important for your design. Whatever it may be, it has to be repeatable. So it has to dispense the same amount of fuel in the same time period within a very tight tolerance. There's a focus on the environment. There's nozzles called vapor recovery nozzles, which are in use in certain states, for example Ohio, where you can't find a regular fuel nozzle. They have vapor recovery nozzles which draw the fuel out of the air and the fuel vapors out of the fuel tank and store it in an underground tank for later use. So here are some of the regulatory bodies that set some of these standards. We got the TSSA, which is big in Ontario, and they go around and measure the amount of fuel which is being dispensed. We have the California Air Resource Board. One example of a regulation they set is the amount of fuel that's allowed to be left in a nozzle after pumping. The EPA, or Environmental Protection Agency, they set limits on the flow rate. For example, 38 liters per minute is the industry standard. What happens if you go above that? You'll get something called splashback. So you'll be pumping fuel when your tank's full. The fuel level will rise so fast it'll splash back on you. So that's the reason for that. We have the Society of Automotive Engineers, which determines more of the dimensional constraints on your nozzle. So one big one would be the location of the sensing port, because that determines how full your tank's allowed to be. So these are some of the major bodies. If you wanted to do more research on standards, this is where to look. All right, so you got this cool new idea. How do you make it happen? One example would be your ergonomically friendly nozzle. What are the steps you got to take before you start designing. It doesn't have to be an ergonomically friendly nozzle, it could be any idea you have. So starts off with coming up with an idea. Then you got your market study, your patent search, and feasibility study. So I'll talk about a little bit about those right now. Step one, idea generation. This may come easier for some of you than others. If you find you have a hard time coming up with an idea, I suggest paying attention to the problems around you. Don't let it just pass through your mind. Look around, see what people are struggling with, right? And think about it. Why are they struggling with that? Is there a way we can make that better? Keep your mind open to others. Listen to what other people say around you, and don't be so dismissive about it. If they come up with an idea and it sounds silly at the time, just mull over it for a little bit and take into account what they're thinking. Find your passion, something you like to do. Because if you come up with an idea and you pursue it, chances are you're going to be spending a lot of time on it and a lot of time thinking about it. So you want to like what you're thinking about and like what you're doing. Ask questions. Ask questions to industry experts, your professors. And lastly, if you're working in a team, brainstorm. Bounce ideas off each other. It's a good way to get your creative juices flowing. Alright, so now you've got your cool new idea. What's your next step? Do a market study. Does it exist today? And if no, if it doesn't exist, why not? Is it something people are going to buy? Is it something people need? Is there a technology out there that accomplishes something similar? So if your idea, you want your idea to be different and better than what's out there. You don't want to be doing the same thing that another technology is doing, just in a different way. So that leads us to, what's your competitive advantage? What makes you better than the rest? And as for market validation with an ergonomically friendly nozzle, we can see an industry leader, OPW, on their new series, their new line of nozzles called the Advanced Nozzle. They have a feature called the Soft to Open. So what that does for us is it recognizes that, hey, an ergonomically friendly fuel nozzle is needed right now, and it actually is an industry problem. So I got a video here. It'll be hard to read because of the projector, but the YouTube link's right here. If you wanted to take a look at it after. Essentially what they've done is they've changed the size of the pockets so it's easier to open, and they've tried to move the pockets out of the fuel flow path, so it also makes it easier to open. Okay, so you did your market study, you didn't see anything out there like it, now what? Just because it's not on the market doesn't mean it doesn't exist. Somebody still could have had the idea and patented it, but it just didn't come up, it just didn't make it to market. So, do a patent search. How many people here have done a patent search before? Awesome, so a few of you. If you haven't, an excellent tool to use is Google Patents. Very easy to use, user-friendly. Just type in, generally what you're looking for. It'll pull up a bunch of ideas. If you got really serious about your design, you can hire an agency or a lawyer. Typical cost is about $450 to $800 to do a patent search. Patents and reading patents, searching for patents, it's all extremely tedious. I suggest from the beginning, set up a good tracking system where you know what patents you looked at, how it relates to your design, and kind of you can even put a rating system in. Say, this is a priority 5. I should really pay attention to this because I could infringe on this, for example. And if you get really, really serious about it, you can get a letter of patentability from your lawyer. What this does, essentially, if you design, say, a dripless fuel nozzle, for example, and I go in and I'm manufacturing them and I'm selling them, and then I later find that I infringed on somebody's patent, they can come back and sue me for maybe 800% of my revenue. What a letter of patentability does is it shows the courts that, hey, I did my research, I have a letter from